Okay, zeros and end behavior. So we've kind of talked about this. Most of this should actually be review. We're just going to change the way that we wrote the end behavior. Okay, so you can skip that first page. You can read it if you need the extra help, but let's just get right into this. So without graphing, we need to determine the end behavior of each polynomial. So I want you to draw this table. Draw a 2 by 2 box, kind of like when we were multiplying polynomials. Draw that same box. Except for now we're going to have positive, negative, and even and odd. Okay, so make sure you have this drawn down. It is so important that you draw this down, okay? So if it is positive and it is even, your graph is going to look something like this. The ends are both going towards infinity. If it is negative and it's even, they're both going down, so they're both going towards negative infinity. If it's positive and it's odd, that means it starts negative and it ends positive. So it starts at negative infinity, ends at positive infinity. If it's negative and it's odd, it starts at positive infinity and it ends at negative infinity. Okay, make sure you have that written down with the pictures and with everything there. Okay, so if we look at this first one, we're always looking at the one with the highest exponent. So that right there. Now, we're going to see if this is positive or negative. Well, there's a negative sign there, so that is negative. And then the exponent power, 3, is an odd number, so that is odd. And we are going to start positive, end negative. This is the part that's a little bit different. So I want you to write it as the limit, and then as x goes to negative infinity, so this piece right here, this is 1, and this is the other. And I want you to write it like this every single time. So limit as x goes to negative infinity, f of x goes to some number. And the limit as x goes to infinity, f of x goes to some number. Negative infinity will always be on top, infinity will always be on bottom. And then this tells us exactly what these need to be. So it starts at infinity and it ends at negative infinity. That's why this chart is so important. It will tell you exactly where you need to put them. Okay? Let's look at this next one. So that is positive, and it's even. So now we're looking at that right there. And they're going to both be positive infinity. So we write out our limits. So the limit as x goes to negative infinity, f of x goes somewhere. Limit as x goes to infinity, f goes somewhere. And they're both positive, so they're both going to be positive infinity. This last one, that's negative, and, oh my goodness, I did this wrong. You silly. Gosh, sorry. Okay, we're going to just write this one out. So, you have to look at the highest exponent power. Okay, so here, my highest exponent power is this one. Now, that is negative. And it is even. Okay, ignore that circle. So negative and even, so it's going to be this one right here. Now we're going to write out our limits. So limit as x goes to negative infinity, f of x goes to something, and the limit as x goes to infinity, f of x goes to something. This tells us what that something is. Okay, so this says they're both negative, so this is going to be negative infinity. And this is also going to be negative infinity. Okay, it always has to be the highest exponent power. Don't make the mistake that I just made. Okay, it always has to be the highest exponent power. Okay, I'm just going to click through this fast because that's wrong. Okay. Now, to determine the number of possible zeros without graphing, you just look at the highest exponent number. So this one is a 3, so we have 3 possible zeros. It's as simple as that. That's what the fundamental theorem of algebra says. The highest number of zeros, that is how many possible numbers of zeros there are. It has to be greater than 0, though. This one, we have 4, sorry. So there are 4 possible zeros. Okay? Now this example 3, we're just kind of going to put it all together. And we're going to find zeros, which is simple, especially because I give this to you in factored form. So first we're going to graph it just to see the basic shape. So there's the basic shape of that. And I didn't show the whole graph, sorry. Now we're going to identify its end behavior. So this is positive and it's even. So if you go back to that chart that we were looking at on the last slide, that means that they're both going to end positive, right? You should have that written on this page. They're both going to end positive. So this is going to be the limit as x goes to negative infinity, f of x goes to positive infinity, and the limit as x goes to infinity, f of x goes to infinity. These right here, this is the only thing that's ever going to change. Nothing else is going to change, just those. Okay? What's happening? Okay. Then we have to find the zeros. And since this is already factored for us, we're just going to set the factors equal to 0. So we have x minus 5 equals 0 and x plus 4 equals 0. So you get x equals 5 and x equals negative 4. And the only thing is you have to write these as points. So that's going to be 5, 0 and negative 4, 0. Okay, if they're not written as points, I do mark them wrong. Okay, let's do one more. So if we have this right here, graph it in your calculator and you get a graph that looks like that. Now, end behavior, it's negative and it's odd. And I'm using this right here. Negative and it's odd. Okay? So I'm going to look at this table, and that means it's going to start positive and end negative. So that's going to be the limit as x goes to negative infinity, f of x goes to infinity, and the limit as x goes to infinity, f of x goes to negative infinity. Find the zeros, so we're going to have x minus 3 equals 0, x plus 2 equals 0, and x minus 1 equals 0. So x equals 3, x equals negative 2, and x equals 1. Write them as points, so that's going to be 3, 0, negative 2, 0, and 1, 0. Okay? Save that last example. Remember to take the quiz. You guys rock. Okay, bye.